Hello, hello, hello. Hi, everybody. You hear me? Okay, cool. So, the task for today, the task for today is, for me, is pretty simple. I'm going to show you a few questions, the likes of which you can expect to have in your test. So the test, as far as I understand, is planned for the 9th of April. Otherwise, I don't know the time, the place. Ilya Makarov will tell you. So I'll show you about 7 questions, and I'll select I think 4 of them or 5 of them for the test. Yeah, I'll try to make sure that the questions are exactly for 2 hours. So basically, all of the questions are about 2 things. One thing is how to query various types of data, and another one is how to represent various types of data, either in the form of RDF or RDFS, or in the form of a OWL ontology, in whatever language you use there. Yeah, so I'll show you questions of this type and comment on how to answer them. But basically, I've given you examples in the lectures. All right, so question number 1 is like this. I give you an XML document, something like this, and there are 2 questions. Yeah, one question is give a tree representation of this XML document. Yeah, this is just for you to understand what's where is what. Yeah, so what I'm expecting for you to do is to draw a picture like this. Say you start with the root. Okay, let it be just root. Okay, then you look at the first element in the document. Okay, so you have here collection. Yeah, so on the root you place a collection node. All right, don't forget that in in XML, all nodes are placed left to right, and the order matters. Yeah, so after the collection, here we are looking the first element, which apparently is artist. Here it is. Okay, so I draw here artist. The next one will be what? The next one will be band. All right, let it be band. Yeah, and so on. Band, then again band. Yeah, and then artist, another artist. Okay, then we come back to the first artist and have what? Name, Robbie Williams. So then we have name. Yeah, and then under this name we have Robbie Williams. And this is a leaf. Yeah, and you draw such a picture. for the whole document. Okay, so our artist, then what? CDS. What is CDS? CDs probably, yeah? Okay. So CDs, then CD, and then root box. Yeah, and then CD something, swing. Yeah, and so on. Okay, so this is task number 1. And task number 2 is to write or give an indication how would you write XPath queries that return nodes or elements with some information. Yeah, say the first one is the names of all artists. Yeah, of course, I don't remember the syntax of XPath myself. I don't use it every day. So what I would do, I would before the test, I would have a look at the typical constructs in XPath queries and say names of all artists, names of all artists. Yeah, so what I would, yeah, so we are looking for this pattern. Yeah, we have to find an artist and then the name. Yeah, or maybe if there are no other name elements, then just name. Yeah, so I would write something like this. Wherever we go in the document, we need artist and then name. Yeah, and then you can add. You don't have to add. You can add here also text and brackets. Yeah, but this is what I expect from you. Something of this kind. Right, okay, of course, there are more complex things. For example, the next query is more complex. The name of the artist who recorded the root box CD. So there are many ways of doing this, and one way, say, like this. Artist, then in brackets, square brackets, CDs / CD equals root box, yeah, and then name. Yeah, so as you understand, this thing in square brackets identifies this. Yeah, so this CD root box, yeah, says that take this artist. Yeah, take this artist and return the name. Yeah, so there are 2, 3, 4 typical constructs for this. Don't forget that there are also there can be also okay. Have a look at the XML document I gave showed in the lectures. Yeah, and I showed you XPath queries there as well. Okay, so this is question number 1. It's pretty easy. I don't know whether I included it or not, but yeah, have a look at this example and the example in the lecture slides. Yeah, I gave an example about books and authors. All right, now question number 2. Question number 2 is a similar story, but now for RDF documents. Again, I give you some document. Say, like this, and I ask you the following. Describe in English the content of this document. What I mean is that your description should be understandable for a person not familiar with the syntax. Yeah, just exactly what this document says. That's number one. Number two, give a graph representation of this document. Right? Maybe you should start with this. Yeah, I think in your most probably in your test, it will be a little bit more complex. But the questions will be like this. Yeah, describe in English the content of this document, give a graph representation of this document, maybe represent this graph in the turtle syntax. Maybe write a SPARQL query. We'll consider SPARQL queries a bit later. Okay, so what do I expect? Yeah, let's have a look at this document. Okay, so this is a prefix which describes what some namespaces. Okay, who cares? Yeah, for your description in natural language, it's irrelevant. Cool. Now, well, then you don't understand what's RDF description about nonsense. Yeah, have a look at the lecture slides. Yeah, and there are examples and explanations. In 2 words, remember that in RDF everything is a triple, and this is an XML syntax for describing such triples. Yeah, and it's written description. All right, then it describes some triples. About UK, aha, cool. So the UK is the subject of a triple or triples. So what you do, you start with okay, so UK. Fine. Then UK, aha, type country. Yeah, so UK is of type country. So you draw an arrow and write here RDF type. And here there'll be a resource country. At this point, I don't care about the full URIs, yeah, because before country, we need, well, some prefix. Yeah, but so what is the base? Base is geography.org, so it will be http://geography.org/country. Yeah, that will be the full URI. Okay, I don't care. All right, let's read further. Oh, the description ends. Fine, so this is one triple. Now, the next description about capital of. Capital of. What is capital of? Capital of is of type property. It's very difficult to draw. So it's a property. It's a property. The domain is city. Range is country. Right, so let me draw it some capital of. Now it's of type property. Yeah, RDF type. This is property. And what are the RDFS domain? Domain is what? Domain is city. City, and range is country. Capital of, then the range will be here. range, country. Right, country is a class. Okay, so I write here something like type class. Okay. City, so London. Ah, look at this. This is a, there is a catch here. Here, it's not description. Oh, sorry. Here, it's not description. It's written city. Yeah, so if you consult the lecture slides, you'll see that if instead of description, I use some other words, or anybody uses another word, then this word means the type of the subject. So this means that London is of type city. So let me, London. And London is of type, instead of RDF type, I can simply write A. So London is a city. London is a city and capital of UK. So this will be capital of. Right, what else? City is a class, fine. This is class. Oh, class, we already have it, so it's not like this. It goes there, yeah, of type class. Okay, so something like this. Yeah, and then how you write in English. So UK is a country, which is a class. London is a capital. I say a, not the, for the reason that in RDF we can't say, you know, unique. Yeah, it's London. It can be one of capitals. You can write in the document many other things. A capital of is a property whose domain is city and whose range is country. Yeah, therefore, London is a city. No, it's not therefore. Oh, therefore, London. Actually, this information, yeah, it's twice. Yeah, so if it is a capital, you don't have to write explicitly that London is a city. Yeah, say these two things, one of, say here, if I wrote description, the meaning would be the same. Okay, this is a graph and in English. Then represent this graph in the turtle syntax. So in the turtle syntax, don't forget that there are namespaces, and so you have to use these namespaces. You can introduce some namespaces for your concrete example, yeah, and use some prefix, I don't know, x, for example. Or you use namespaces from this. Okay, anyway, it's in your example. So eggs UK RDF type country, tree and full stop. Yeah, instead of RDF type, you can write A. And so on. So we just write all things. What I want you to check is all the, there are, I don't know, 5 or 4 things you'll have to remember. For example, but it's written here, capital of X, capital of, then RDFS column, domain, and then x city colon, and so on. Right? There are very few standard things taken from RDF or RDFS. Yeah, like type, domain, range, property, class, and so on. Have a look in the lecture slides. So what else? Yeah, that's it. Again, I may add to a question like this a sub-question, right? An RDF query. Sorry, a SPARQL query that finds all the, I don't know, capitals or something. Okay. Now, question number 3. Now I give, so there'll be a few things about representing natural text as RDF or OWL or whatever language we had. Now, the question number 3 is pretty straightforward because there is no story, just I give you concrete sentences. Yeah, and your task is to model this information. Yeah, maybe you should start modeling by drawing a graph representation. It always helps. And because the second question will be writing SPARQL queries, yeah, so maybe it will be helpful as well. All right, so document 1 has been created by Paul, and then there is a date. Right. So you should start thinking. Okay, so first you need some namespace. I don't know, my namespace. Okay. My namespace. Boom. And in this namespace, you give a URI to document 1. Yeah, say it will be, say, doc1. Right. And then you start thinking, do I know anything about the vocabulary to be used here? There are 2 ways. A cool way is that, okay, you just look in the lecture slides and you recall, aha, that guy used, say, Dublin Core. Yeah, there are some pages where I use the vocabulary from Dublin Core. Yeah, and there is a special namespace DC, yeah, Dublin Core. And in Dublin Core, there is a vocabulary where with creator. Yeah, that is the somebody or that produced the subject. Alternatively, you can invent your own vocabulary, but be consistent. Say you use, instead of DC creator, you use your own my namespace, I don't know, created. Or produced, or whatever word you use. Yeah, fine. Then okay, fine. I understand that. This stands for created. Now, who created? We need Paul. Yeah, probably Paul should come from your namespace, or it can, again, it could be cool if you use, I don't know, say FOAF or something. But it doesn't matter. Let it be my namespace, Paul. Full stop. It's not over yet. So we have to say that this document was created on a specific date. All right, so then you have to again invent something or recall that. So if you actually use semicolon here, yeah, then you don't have to repeat the subject. Yeah, and if you look at my examples, then you'll see that in DC there is date. Which means that my NS doc1 was the date yeah, is the date is what? 29/11/2013, and here you should add X as the date. Yeah, so that the machine knows how to interpret this 29/11/2013. Yeah, full stop. Yeah, this is all the information about doc1, creator and date. So what is the problem here? The problem is to invent some vocabulary for creator, for who created the document and how to represent the date. Yeah, so you have to invent two properties. Yeah, say, okay, document 2 and look, say I would start writing probably I would start solving this problem differently. I would say, okay, doc1, what do I want to say about doc1? Okay, somebody created, this somebody is Paul, and then what date? Date, and this 29/11. All right, so a picture like this, which then can be represented as proper triples. Okay, so this is one thing. Number 2 says that document 2 and document 3 have been created by the same author. Yeah, and about the author, we don't know anything. We only know that it exists, and we only know that it's the same for document 1 and document 3. Right, then what would we add here? Doc 2, doc 3, creator, and here we don't know. For don't know, or for many other things, yeah, check out in the lecture slides, we use blank notes. Yeah, blank notes start with an underscore, then colon, and then some ID. This ID has no meaning whatsoever. Yeah, the only thing is that it is the same for doc1 and doc3. Yeah, this is document 2 and document 3 have been created by the same author, unknown author. Right, now document 3 says that document 1 has been published by the W3C. So this is a statement about statements. A statement about a statement. To represent things like this, you need a special construction. And you should have a look at this construction. So let me recall. Okay, I'll do it as triples. So how I would analyze this situation. Yeah, so document 3 says something. Say, I don't know. I give a name to this something. It will be an anonymous, and I say blank note like this. Yeah, then I would write my namespace doc3. Then my namespace says or claims or whatever, and then this. All right. So this is S. This is the statement. Right? And now I write that I write what says that this S is of type RDF statement. Yeah, now the machine knows that it's a statement and expects the triple of this statement. Yeah, and as then RDF subject. What is the subject of the statement? Doc1. My namespace doc1. Then it says that RDF predicate. Predicate is what? Published. So predicate invent a I don't know, DC publisher. Okay, and the last one will be RDF object. And object will be, I don't know, some URI for W3C. I don't know, HTTP. I don't know, w3c.org, for example. Or introduce a some short name for this. Okay, I'll show you another example about statements a bit later. Yeah, but this is the task. If I have that, well, let's go there right now. And where is it? Yeah, number 6. Represent, if possible, the following information in RDFS using the turtle syntax. So you will have questions like this. And in some cases, you can represent in RDF and schema, in some cases, not. But then I expect you to give some arguments why it is not adequately representable. Yeah, say, recall what can be done in RDFS and explain. Yeah, say, for example, in RDF, we can't represent negative information. Yeah, so not in a usual, with the usual meaning isn't representable. Okay, so what do we have here? We have John believes that Mary wants to marry him. Yeah, I think we have seen this example already, or maybe I forgot. So we have what? We have John believes, I don't know, X. Yeah, what is X? X is a statement, and X is actually a statement. John believes X, and X is this one. Right? And what is then I write like John believes this is a RDF statement. Then I have RDF subject. Subject is what is the subject? Mary. What is the object? object. What is object? Wants. Okay, let it be wants. And what is the no, sorry, it's not object. It is predicate. Predicate. Once. What is the object? What does it show? Here it's tricky, yeah? It's again statement. The statement is Mary marries John. Mary wants something to happen. And what is something? It's a new statement. Mary wants to marry John. So I write RDF object, another blank, say Y, and Y is also a statement that says that Mary predicate. What does she want to do? She want to sorry. So this is the goal, and this is an act, marrying. This is predicate. And predicate is marry, these two R's, and finally object, RDF object. And whom? Him. Him is John. Yeah. So this is a tricky thing. Yeah. So you have to disassemble a complex thing like John believes that Mary wants to marry him into two statements. John believes one statement, yeah, and once the statement X includes another statement Y. Yeah, otherwise the construction is pretty similar and symmetric. Yeah, there are many situations like this. Okay. So the next one, the next example is this, number 4. And number 4, this scenario is an ontology-based data access. And what I want you to do is to show how to transform relational databases into RDF triples. Yeah, and the scenario is given like this, that you have one table, another table, yeah, and you try and figure out what is written in the table. Okay, it's ID, first name, last name. Yeah, another table says what? ID, first name, last name, position. Yeah, and then here we have some magic numbers. And the magic numbers, the meaning is here. Yeah, so Anna is full professor, Edward is a postdoc, Rachel is an external teacher. In 3.4 we have a phone number. In 3.4 we have a phone number. Phone number, I don't remember. If you write simply as, you mean this one? is it integer? I don't think so. Integer probably means that you can perform some arithmetic operations, right? And here it is just a sequence of symbols. So if you just write in quotation marks, it should be fine. About the telephone now. Oh, by the way, so here somebody knows, yeah, somebody, don't invent names for somebody, you don't know this somebody, use a blank node. Yeah, so for somebody says that document 1 has been published by, sorry, no, somebody knows somebody else who is a lecturer whose phone number is, oh God, what is this? Okay, let's try. This is about blank node. Right, let me think. Somebody, okay, I use square brackets, yeah, like this. Yeah, it's a blank node. And then I use knows. Okay, in the friend of a friend, there is this property knows. And then what? Somebody knows, aha, I open somebody else, again a blank node. Okay, let me make it simpler. A knows, and here I write B. Somebody knows somebody else, so this B is somebody else, and then I write B is a of type lecturer. And B has telephone number, I don't know, and lecturer, and for of, I forgot, do they have phone? I think they do have phone or something like this. Phone, and I write like this, 6, 5, 4, 3, 2, 1, dot. Something like this. I won't punish you for imprecise syntax. Yeah, just show that you understand the general idea. Yeah, if you forget, you know, data type or something, it's less important. Okay, now question number 4. So you have table 1, table 2, table 3, table 4. Yeah, and there is some information. Yeah, say in table 3 we have what? University course or list of university courses with IDs. In table 4 you have relation between teachers and courses, and so on. So these tables are relational, but what I want you to populate classes and properties. Right, so I want you to have a look at the slides, OBDA. And there are examples which basically are nearly the same as this example, yeah, but a different setting. There we had what? Movies. Here we have courses, students, and lecturers. Yeah, but the setting is everywhere the same. The setting is what? You have to write two things. You have to write target, target, and you have to write source. Target is what kind of triples you want to create. Yeah, say if you want to create course, then the target should be, well, you invent some, or you use some known namespace, say uni1 core. Yeah, so this is a class, and you populate it with course ID, right? And it will be, so you want to construct triples like this. This will be a URI of a course. Yeah, and you will have many such URIs. And all of these URIs will be elements, yeah, that is RDF type. They all of them will be of type course. That is, you populate this course with concrete URIs, which refer to courses. Yeah, this is what I mean by populating. Yeah, so you have to construct triples like this. You have to construct triples like this. And they are constructed by finding this CID. Yeah, and how to find this CID, course ID. To find them, well, you need a query to the database, and this is the source. And the source says what? From where we can find them? We can find them, say, from this table. Yeah, and we write select CID. This is the name of this column. This one, yeah, you see CID, and then you write from where, and this is the table uni1 course, uni1 course. Yeah, that's it. So in this particular case, the SQL query is pretty simple, but in my examples, in the lecture slides, or try and answer this question, yeah, so you'll see that you don't need too sophisticated SQL queries. Okay, so just refresh SQL in your mind. By the way, I forgot to tell you that in the previous number 3, there are these 2 sub-questions, yeah? Represent the following query in Sparkle. So you should have a look at Sparkle. Sparkle and SQL have a look at these 2 together, at examples. Yeah, you don't need any theory of this. But in order to write queries, you have to know some basic things about your RDF graph. Yeah, say here, find the authors of documents together with the date of creation. Do we have? No, we don't have. Let me recall what we had. Find the authors of documents together with the date of creation. And we had what? We had doc 1. I forgot what was that. It was Dublin core creator. And then we had Paul. And then what? And then we had DC date, and here we had some date. Okay. Then in our SPARQL query, so we need authors of documents and the date. Yeah, so we need two values. Or we introduce two variables for this. Yeah, so, and this is what we are going to select. Select question mark, I don't know, A, question mark D. We need pairs. This will be these pairs, the values for these pairs will be our answers. And then how, so let me draw a picture of this document. So we had doc1 creator, and this is name, and this is author. Yeah, so this will be that will be a value for author, and the date is creation is here, date. Yeah, and this will be question mark D. So I need a pattern of this form, right? And this will be the result. And the value of this one, I don't care. Yeah, so I introduce a new variable. So select this and this where brackets opening closing, what somebody X was creator of question mark A, full stop. Yeah, this is this triple here. Yeah, so this is the green one, and then date again question mark X DC date question mark D, and this will be blue, and the blue part is here. Right, so the machine will take this pattern and find how to match this pattern in the actual RDF graph. Yeah, so it will match the green part along the green line and the blue part along the blue line. The value for X isn't returnable, but the values for A and D will be returned. Okay, and so have a look at the SPARQL constructs. For example, here you need if available. Yeah, that will be optional. Yeah, and there are quite a few constructs. Have a look at all of them. Try to recall. Yeah, in particular, there are various filters, and there are bound variables and not. So have a look at this. So those examples which I gave in the lecture slides, you can expect that similar examples will be in the test. Okay, where are we? Then I'll give you a story. Yeah, it will be a story similar to this one, probably simpler. I'll invent some story or take it from somewhere, but it's, yeah, well, so this is a text about some school. The elementary school in Freiburg has 3 employees. The 2 teachers, Mr. Meyer and Mrs. Schmidt, and schoolmaster, Mrs. Köster. In addition to their administrative duties, Mrs. Köster or Koster also does some teaching. In particular, assigned Mr. Meyer is assigned to first graders and so on. So I ask you to represent this as an RDF document. Okay, so you should invent a vocabulary, a consistent vocabulary for this little world I described in my sentences. Yeah, probably it will be half shorter than this. This is basically the main task, to find a vocabulary, right? And maybe it makes sense to start designing your vocabulary with, say, classes and properties. Yeah, classes and properties. This what kind of classes do you need? Say, what do we have? Elementary school, right? Probably here we are speaking about one elementary school in Freiburg, but there is another one in Berlin, or many of them in Berlin, and so on. So maybe we need a class elementary school. Yeah, so, and you write that elementary school is of type RDFS class. Yeah, what else do you need? Oh, if you read there, I don't know, maybe you need employee. Maybe you need teacher. Maybe you need schoolmaster. Maybe you need pupil. Yeah, these kind of things. Yeah, you just list them so that in your representation of the document you could use these classes. Or properties, like what kind of properties we have. Say maybe we have we have names, for example. Yeah, we have some people and we have names. So property, say name, yeah, with some namespace is RDF type RDF property, and then you say that domain. Yeah, what is the domain? RDF as domain. Who can have a name? Yeah, probably a person. What can be a name? Yeah, RDFS range. Range, it will be what? Range is a string. Yeah, so you write like in XML, X as D2 string. Yeah, and so on. So you first introduce your classes and your properties, and then you use this terminology and your rights for concrete objects, yeah, to actually to express what's written there. Yeah, for example, you give some URI to the school. I don't know, ASFR, Elementary School of Freiburg is RD, is of type L school dot. Yeah, and you may say that or semicolon, and it has name, and then give here name, Elementary School Freiburg. Yeah, and so on. And then you have properties, I don't know, teaches, and somebody is of type pupil, and so on. But be careful that there can be some say pupils, as far as I remember, whose names aren't given. So there you use anonymous names, that is blank notes for those pupils. Yeah, okay, and otherwise it's the same as we've done before. Yeah, so the essence here is that you, for a story, a short story, you create enough classes and properties so that it can represent all the sentences, all the information given in the text. Okay, and the last question probably will be like this, like number 7, where I want you to represent some more complex knowledge in the form of ontology. Now, for ontologies, what I showed you was the ontology editor Protégé, yeah, and there I showed you some language. Yeah, I don't expect you to write everything in that language. I expect you to write it somehow. So let me try and explain. So what do we have in question 7? There are a few statements, and now let me remove this. Yeah, and I want you to represent the statements. But in principle, it should be the web ontology language as shown in the as I showed you on my example in Protégé. Yeah, and in Protégé we had constructions like subclass or equivalent classes. Yeah, and similar here. I don't want you to remember the exact syntax, but some indication would be nice. For example, what is written here? Every pizza is a meal. So I want you to start thinking what well, apart from that, it would be nice to have a pizza now. What is this? Every pizza, right? So probably pizza is a class, something. This is pizza. It's a class, and there can be many pizzas, yeah, and it's a meal, yeah, can be eaten. So meal, there can be other classes in meal, say, I don't know what else is meal. Pasta is meal. So what you want to say is that there is a class pizza, which is a subclass of the class meal. Oh, subclass, subset, cool. So I just write like this: pizza, subset, meal. Done. All right. Pizzas always have 2 toppings. Who said this? Anyway, don't invent things, yeah? Represent what I ask you to represent. Pizzas always have 2 toppings. Then, how is it done in Protégé? In Protégé, it's written something like this: pizza, and then subclass of, and then it was has topping. It's a property. I just think that I have a pizza here. Yeah, this is class pizza. And there are some pizzas here. And what I want to say is that from this, from every element here, there are 2 arrows, which mean at least 2 errors, which mean that we have 2 distinct toppings. Yeah, and these guys are toppings. Topping. Yeah, this is what we want to represent. Yeah, whatever pizza we take, there must be at least 2 errors going to topping. Right, so, and in Protege, it was written something like this: pizza subset of has topping, and then it was written at least 2, yeah, or we write it at least 2 topping. Or if we use the description logic, it will be syntax, it will be like this: has topping dot topping. Every margarita pizza has a tomato topping. All right, so we have a class margarita pizza. Margarita pizza subset of, yeah, whatever margarita pizza we have, subset of, and then I write like this: exists has topping dot. So that is, there is an arrow has topping that goes to tomato topping. Tomato topping. Right, so again, to represent things like this, you have to create classes, and you have to create properties, maybe individuals, and you have to write statements. Yeah, the statements can be written in a simulation of the Protege language, or a simulation of description logic, or if you want, you can write in first order logic. Some formal language would do. Okay, and then there is a question: which of them can be satisfactorily represented in RDFS? Yeah, say this one, it's simply subclass of, but every pizza has at least 2 toppings. No way. Yeah, we have no counting in RDF. Yeah, if you refresh your memories about RDF, you'll see that no counting, no statements of this form can be in Protege. Sorry, in RDF. RDF can say only subclass, subproperty, domain, range, and that's it. Yeah, basically. Type is an element. Individual is an element of a class. Okay, so these are the types of questions you will have. Or probably I'll give you 4 or 5, as I said, of questions like this. Yeah, so if you have questions now, ask. Otherwise, have a look at the lecture slides before taking the test, and you will be fine. Questions? Igor. A range is range. You have triples. Yeah, subject, predicate, object. Yeah, this is where the beginning is the domain of the property, and this where the objects can be is the range. Yeah, it's like functions. The domain of a function and the range of a function. In Russian, it should be область определения for domain and область значения for the range. No questions? Okay, guys, then when the 9th of April, it will be warm. As concerns materials, I'll discuss this with Ilya and we'll decide. Yeah, you will be informed by email. Definitely no internet. Otherwise, we'll see. Otherwise, you will take the lecture slides and you will be copying by replacing one word with another one. Yeah. Okay, then take care. It will be warm in April. Can you please give a set of questions with solutions? Okay, what I'll do, I'll publish this file, which I showed you today, and I add solutions. This particular set of questions with their model solutions. Okay? Okay, let me write it down for myself, not to forget. Publish solutions. Okay, take care, guys.